Square root of negative 5, and what was the other one? Square root of negative 13. So we'll look at these two here from the homework first, and then we'll get started with the lesson. Now, when we look at the square root of negative 5, well, the negative is going to come out as I. Is 5 prime? So I can't take the square root of it, so it's going to be I square root of square root of negative 13. Well, the negative would come out as I, and well, 13 is also prime. So we had I squared root of 13. You're welcome.
Wait, what about
12?
Yeah.
Square root of negative 24? Well, we know the I, well, the negative is going to come out as I. So then we need to figure out what the square root of just 24 is. So we could plug it into the yellow calculators or find products. Two numbers that multiply together to give me 24. 4 and 6. Square root of 4 is? And we can't take square root of 6. So we get 2I square root of 6. Any other questions? The first thing we're looking at is the conjugate root theorem. Now there is a lot on this slide here for the conjugate root theorem. If a polynomial px with real coefficients has the root a plus bi, then a minus bi is also the root. Really what it's saying, a plus bi's conjugate is a minus bi. The conjugate root theorem is really just saying the conjugate of a plus bi is a minus bi. And we're really just changing the sign in front of the imaginary term. If bi is positive, its conjugate would be negative. Or if bi is negative, its conjugate would be positive. And that's really it. So I just have this main point of those two there. So if we look at this first one here, what would the complex conjugate of 7 minus I be? What would the conjugate of negative 5 minus 5i? That's it. Yeah. Because it's just asking for the conjugate. Now, before we move on, there is something that's very interesting with conjugates. I'm going to take the first one here, 7 minus I, and multiply it by 7 plus I. I'm going to multiply the two conjugates together. Now, 7 times 7 is 7 times I is plus 7i. Negative I times 7 is negative 7i, and negative I times I is negative I squared. Now, what did we say I squared was? I squared is negative 1. Now, we can mark it out and just say plus 1, because that's really what it is, because the negative and negative would make a, and we just have 1. So really this here is just plus 1. What's 7i minus 7i? So I have 49 plus 1, which is? So wait a minute, when I multiplied the conjugates together, what happened to I? They cancel it out. Do we have I anymore? No. And what's kind of interesting, if we just look at the conjugates, because we said a plus bi, its conjugate is a minus bi for any values of a and b. If we have this set up with any real values of a and b, and we multiply them together, Well, we would get a times a, which is minus abi. Bi times a is going to be plus abi minus squared I squared. Well, I squared just makes this positive because it's -1. Our middle terms cancel each other out, so I'm just left with a squared plus, and a and b are real numbers. So no matter what happens, if I multiply the two conjugates together, our complex conjugates together, we end up with a real number. The imaginary terms cancel out. And that's kind of key, because that's really what this is boiling down to. If a polynomial px with real coefficients has the root a plus bi, then a minus bi is also a root. Because in the ones that we've dealt with and said no real solutions, did the equation have any imaginary terms in it? Well, no, it just had whole numbers, yes? There wasn't any I terms in the beginning equation. So if I get a plus bi as a solution, I have to also have a minus bi. Because the only way the i's would cancel is if I have the conjugates. So that's kind of a big hint, because if we know that a plus bi is a solution, it's a given a minus bi is also one. They go in pairs. So let's just find the complex conjugate of 2 plus 4i, -2 plus 4i. What about 3 minus 6i? (10 minus 2i? Almost. We don't change the first one. (-4 minus 8i? Let's, because I think these are the last two, yes? (-4 minus 3i would be? And last but not least, let's throw one more in. How about (-7i's conjugate? How about 8's complex conjugate? Well, because really what we can say is this is plus 0i, so its complex conjugate would be 8 minus, which is really just 8 and 8. And that's it. We're ready for division. 4 plus 3i divided by 1 minus 2i. Go on, type it in. And what did it give you? Did you use the fraction bar? So actually use this here? Okay. Huh? It will not do it with the fraction bar. If we do alpha y equals enter and type it in that way, it will not solve it. And I'll show you exactly how Drayden got the answer doing it in the calculator. But first, let's actually work through and see what it's doing. We cannot have imaginary terms in the denominator. We don't want them in the bottom of the fraction. Now, as we just saw with complex conjugates, if I multiplied 1 minus 2i by its complex conjugate, the I terms would cancel out. So what we can do is we can multiply the top and bottom of this by its complex conjugate, which would be over 1 plus 2i. So really, what are we multiplying this fraction by? 1. Anything divided by itself is 1. Now at this point here, we would multiply these together. So in the numerator, we would have 4 times 1, which is 4. 4 times 2i is plus 8i. 3i times 1 is plus 3i, and 3i times 6i squared. Well, the I squared is really just going to change that from plus to minus. Now in the denominator, we have 1 times 1, which is 1 times 2i is plus 2i. Negative 2i times 1 is negative. And negative 2i times 2i is negative 4i. Because the I squared is just negative 1, and negative 1 times negative 4 is plus 4. And yes, the negative, or the 2i and negative 2i in the denominator would cancel out. 4 plus, which is 5. In the numerator, 4 minus 6 is 8 plus 8, 11i. Now, in most places, they're going to want us to split the fraction apart. Because if we have 2 or more things being added in the numerator, we can break it apart. We can't do that with the denominator. The denominators would be the same. They would both be, the first one would be negative 2. And we would get this here. Okay. We can check it here again. Now, did you get decimals? Okay, we'll check it here in a minute. Huh? For where? The I that you put in there, type it in by itself. Just do second, or however you pulled up I, and just hit enter. Second decimal is the I. Is the imaginary I. So this is the final answer here. Now when we break it apart and get the final answer, will the denominators always be the same? No. Because if we had, say, negative 5 plus 11, well, negative 5 over 5 is 1. Because if one of these can reduce, then we would reduce it. So the denominators won't always be the same. But before we reduce, when we split it up, they would be. Any questions on this here? Let me get, well, let's clear that out. I'm going to grab a note sheet so I can. So let's try this one in the calculator, the second one. So we know that, because you did alpha y equals enter and typed it in, yes? Let's try a little different. Let's say parentheses 1 minus 4 second I close parentheses. Now what operation are we using? Because we're dividing, aren't we? Parentheses 2 plus 3 second I. If we hit enter, okay, so it will give us the answer, yes? Is there a way for us to turn this back into fractions? Math? Enter, because the first one is fractions. Enter. It will do it, we just have to use a few more steps. It does not like it as in the fractional form, alpha y equals enter. But if we rewrite it as a division, because that's what we're really doing, we're dividing these two things, it will do it for us. Questions on this here? Now, one of the big things is that you will still need to use parentheses around both terms. So if we look at number C, the equation is 2 plus 5i, close parentheses, divided by 4 second I. Because it might be very tempting to write this. And here I think it'll work, but it'll be good to make sure, yep, to put parentheses around it just to be safe. Yep. 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 Uh-huh. Because without those parentheses, it's dividing it by 4 and then doing the multiplication of I across the top. It sees it as two different terms. It sees it as that divided by 4 and the whole thing times I. So putting the parentheses around it, even though it is one unit, we still need them. Questions on this here? Math, and then it should pull up fractions. There's another way to get to it, and that's through alpha y equals. If we look down at the bottom, it is the actual kind of toggle key, because that one will do fraction to decimal and decimal to fraction. The math enter is just going to fraction. Any other questions on this? We need to see another example of one of these. All right.